I am unable to access the April issue of ECM Magazine, so I cannot provide any information about the ad. In order for me to assist you, you will need to provide me with the specific context and details of the ad. Without those details, I am unable to give you any information. I can provide information on a wide range of electrical topics, but I am limited to the information I have already been trained on. Once you provide me with specific details from the ad, I can then do my best to assist you. I can then provide information regarding electrical safety, wiring methods, overcurrent protection, grounding and bonding, equipment installation, and conductor selection. Electrical safety is paramount, and adhering to safety standards is essential to prevent electrical hazards. This includes using appropriate personal protective equipment such as gloves and eye protection, de-energizing circuits before working on them, and following lockout/tagout procedures to ensure that circuits remain energized. Wiring methods encompass the techniques and materials used for installing electrical conductors. Common wiring methods include conduit systems, cable trays, and direct burial cables. Each wiring method has its own set of requirements and limitations, so it's important to select the appropriate method for the specific application. Overcurrent protection is designed to protect electrical circuits from excessive current flow, which can cause overheating and damage to equipment. Overcurrent protection devices include circuit breakers and fuses, which are designed to interrupt the flow of current when it exceeds a predetermined level. Grounding and bonding are critical for ensuring electrical safety by providing a low impedance path for fault currents to flow back to the source. This helps to prevent electrical shock hazards and reduces the risk of fire. Equipment installation involves the proper installation and connection of electrical equipment such as transformers, generators, motors, and control panels. It is important to follow manufacturer's instructions and applicable electrical codes when installing electrical equipment. Conductor selection involves choosing the appropriate size and type of conductors for a specific electrical circuit. Factors to consider when selecting conductors include the ampacity of the conductor, the voltage drop, and the environmental conditions. I could also discuss general electrical concepts. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. It is the driving force that causes current to flow. Amperage is the measure of electrical current, which is the flow of electrons through a conductor, measured in amps. Resistance is the opposition to the flow of current in a circuit measured in ohms. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it and inversely proportional to the resistance of the conductor. This relationship is expressed by the equation voltage equals current times resistance. Power is the rate at which electrical energy is transferred or consumed in a circuit measured in watts. It is calculated by multiplying voltage by current. Series circuits are circuits in which components are connected in a single path, so the same current flows through all components. Parallel circuits are circuits in which components are connected in multiple paths, so the voltage across all components is the same. Conductors are materials that allow electrical current to flow easily, such as copper and aluminum. Insulators are materials that resist the flow of electrical current, such as rubber and plastic. Transformers are devices that transfer electrical energy from one circuit to another through electromagnetic induction. They are used to step up or step down voltage levels. Motors are devices that convert electrical energy into mechanical energy. They are used to power a wide range of equipment, from small appliances to large industrial machinery. Generators are devices that convert mechanical energy into electrical energy. They are used to generate electricity in power plants and other applications. Electrical codes and standards are sets of rules and guidelines that govern the safe installation and operation of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association and the Institute of Electrical and Electronics Engineers. The 2017 National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. Article 90 provides an introduction to the NEC, outlining its purpose, scope, and enforcement. Chapter 1 of the NEC covers general requirements for electrical installations, including definitions, wiring methods, and equipment installation. Chapter 2 of the NEC addresses wiring and protection, including requirements for overcurrent protection, grounding, and bonding. Chapter 3 of the NEC covers wiring methods and materials, including requirements for raceways, cables, and conductors. Chapter 4 of the NEC addresses equipment for general use, including requirements for appliances, lighting fixtures, and motors. Chapter 5 of the NEC covers special occupancies, including requirements for hazardous locations, healthcare facilities, and places of assembly. Chapter 6 of the NEC addresses special equipment, including requirements for electric signs, elevators, and electric vehicles. Chapter 7 of the NEC covers special conditions, including requirements for emergency systems, fire alarm systems, and communications systems. Chapter 8 of the NEC addresses communication systems, including requirements for telephone, data, and cable television systems. Chapter 9 of the NEC contains tables and examples that are used to supplement the requirements in the other chapters of the code. NEC Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on the conductor's insulation type and the ambient temperature. NEC Table 250.122 provides the minimum size of equipment grounding conductors for grounding raceway and equipment. NEC Article 250 discusses grounding and bonding, covering the requirements for grounding electrical systems and equipment to ensure safety. NEC Article 300 discusses wiring methods, covering the general requirements for installing electrical conductors and raceways. NEC Article 408 covers switchboards and panel boards, covering the requirements for the installation and construction of these devices. NEC Article 430 covers motors, motor circuits, and controllers, covering the requirements for the installation and protection of motors and motor circuits. I need information about the ad to assist you further.